Hello, everyone. Welcome back. Good morning. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, broadcasting live Apple Valley, California, People's Republic of California.
Yeah, and we are talking earthquake science today. So
yeah, this is pretty interesting.
It is.
Really interesting. Scientists used advanced hydrophone technology to image the Queen Charlotte Fault, confirming its potential for destructive megathrust earthquakes. New research on the Queen Charlotte Fault system has produced the first images of its subsurface structure off the coast of Haida Gwaii, confirming that northern British Columbia is capable of generating megathrust earthquakes. This research was presented in Science Advances on July 18th, 2025. Would you like to know more?
I don't know why they would be excluded. Alaska has earthquakes all the time.
Oh, we're going to get to it. Let me just advance the slide. Here we go.
Yeah, well, so there you go. Yeah, so all those little dots, right? That's all seismic activity.
And you can see Victoria's bottom right, where that black arrow is pointing at.
Yeah. So, all right. So these types of earthquakes occur when one tectonic plate is forced beneath another. In this case, the Pacific plate being driven under the North American plate. And they are known for producing both intense shaking and tsunamis, which we don't like tsunamis.
Oh.
An international team of scientists from American and Canadian institutions, including Dalhousie University, or Dalhousie, I guess, collected the data using a 15-kilometer long hydrophone streamer.
That's long.
Okay. I don't know what a hydrophone streamer is, but 15 kilometers.
Hydrophones are for underwater sound.
Okay. This instrument, equipped with thousands of underwater microphones, was towed through the region to capture seismic signals and map the deep structure of Earth's crust.
Yeah, so imagine like your Christmas lights, but these are hydrophones under the water being dragged.
Okay.
All right. The findings present the first definitive evidence that the Pacific plate is beginning to collide with and subduct beneath the North American plate in the Haida Gwaii area. In practical terms, this means the region has the potential to generate earthquakes capable of strong ground shaking and destructive tsunamis. In fact, the Queen Charlotte Fault system represents the greatest seismic hazard in Canada, producing the country's largest recorded earthquake in 1949.
Okay, I'm not familiar with Canadian history, but Queen Charlotte, she must have been a queen back
Well,
when
I thought we had Princess Charlotte. I didn't think Princess Charlotte was a queen.
Well, Princess Charlotte is UK.
Yeah.
Oh, is that what this is all about too? Oh, maybe they're just getting ahead of themselves.
Well, Canada is a vassal state of the
British
United
Columbia.
Kingdom. United
British
Kingdom.
Columbia. Okay. All right. You ended with the earthquake in 1949, right?
Yep.
Quote, this region is actively becoming a subduction zone. So understanding the fault structure here tells us about the early stages of subduction zone development. That's a quote according to the lead author, Colin Brandle, a postdoctoral research scientist at the Lamont Doherty Earth Observatory, part of the Columbia Climate School. Okay.
Quote, our study provides the first direct observations of the Haida Gwaii thrust, the megathrust of the system, which can help improve hazard analysis in the region, better preparing residents for future earthquakes and tsunamis, end quote.
The fault is named for the Queen Charlotte Islands, now Haida Gwaii, after being canceled, which lie just north of the Triple Junction. Is that on there, the Triple Junction?
Let me advance the slide and see. Maybe down there it's showing it.
I don't see it. Anyway, okay, where are we at here? The Queen Charlotte Fault continues northward along the Alaskan coast, where it is called the Fairweather Fault. The two segments are collectively called the Queen Charlotte Fairweather Fault System.
The Queen Charlotte fault is an active transform fault on the boundary between the North American plate and Pacific plates. It is Canada's right lateral strike slip, equivalent to the San Andreas Fault to the south in California. The Queen Charlotte Fault forms a triple junction at its southern with the Cascadia subduction zone and the Explorer Ridge, the Queen Charlotte triple junction.
Okay, the Queen Charlotte Fault forms a transpressional plate boundary and is as active as any or as other major transform fault systems, such as, like you just said, the San Andreas or Alpine. And I'm not familiar where the Alpine Fault is. In terms of slip rates and seismogenic potential, it sustains the highest known deformation rates among continental or continent ocean transform systems globally, accommodating more than 50, is that millimeter?
Yeah.
50
That's
millimeter per year
like,
of dextral offset.
That's like you put your fingers across. Your fingers across is probably 50 millimeters, and that's traveling every year.
Yeah, okay. And yeah. The entire 900 kilometer, which is approximately 560 mile offshore length, has ruptured in 7 magnitude 7+ events during the last century, making the cumulative historical seismic moment release higher than any other modern transform plate boundary system. So yeah, I wonder. I've never heard about these faults, but man, that's some activity.
Triple fault. That's got to be some trouble right there.
Yeah, that and what does it say? 7 of these magnitude 7+. I can't remember the last time we've had a 7+ earthquake locally.
Well, Ridgecrest or up north and
I thought those were like
during that World Series.
I thought those were in the 6s.
Oh.
Maybe I could be wrong. Wrong, but 7 is getting up there. Yeah.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Yep. Take care, everyone. Thank you.